So here are your notes for Chapter 9, Lesson 2. And we are putting the date 3/20 at the top. And we have vocabulary word line of best fit. And that is a line that is very close to most of the data points. We're talking about a scatter plot when we're doing line of best fit. And so example number 1 says, refer to the scatter plot about yearly points scored by a certain race car driver. Draw and assess the line that seems to best represent the data, and then use the line to make a conjecture about his score in 2015. And so I'm going to draw a line of best fit through this information. And a line of best fit just has it most closely represents the data. So here you have our line like that, and I am looking for where is this crossing my y-axis. It's crossing in between 3,000 and 4,000 points. And so what do I need to say about this is that the points are very close to the line. But not on the line. And using the line of best fit, we're talking years since 1999, we're talking 2015, we're talking about 15, 16 years. So we're somewhere in here. And so if I go up the scale here to the actual line of best fit, at what value are we at here? I need to go over. So we're at about 5,000 points. So you're just basically reading the graph. That's all you have to do for number 1. For number 2, since the scatter plot shows the number of cellular service subscribers in the U.S., write an equation in slope-intercept form. So if you recall that y equals mx plus b of the line of best fit that's already drawn for you. So you need to first find the slope. So let's pick 2 points that are on the line, like this one here, and let's go all the way up to this one here. And so we changed, well, let's say that this was at about, let's say maybe 115. And so the ordered pair is 1, 115. And so then that makes this ordered pair 8, we'll say 255. They don't give you exact numbers. You have to give what best represents them. So how much did we change? We went up from 115. We went up to 255. So we have a difference of 140 from 115 to 255. Then we make a turn. We were at 1, and we go over to 8. And so that difference is 7. So we have 140 over 7, which reduces to 20 over 1. So that's our x equal. And so where is this crossing this y-axis? It's somewhere between 75 and 100, closer to 100. I'm going to say that that b value, that y-intercept, is about 85. And so now I put this information together. Y equals the m120x plus b, which the value was 85. So what does the slope mean? It means that for every 1 year, you have an increase of 20 20 million subscribers. Each year. Interpret the y-intercept. It means that at year 1999, because the graph goes on from there, had 85 million already. And so the last part of this question, part B, says use the equation to make a conjecture about the number of cellular subscribers in 2015. So we're talking, off the graph here in about 15 years. So let's say that, you know what? Y equals our equation 20x plus 85. We can do this two different ways. Well, we're trying to find the number of subscribers. That's our Y value. And we're talking how many years since 1999? We're talking about 16. And let's just put this in 20 times 16 is 320 plus 85 gives us 405 million subscribers. You can also do it this way. You can say, okay, at 10 years after 1999, we had on the graph about 290 million subscribers. So then we do 11 years, 12 years, 13 years, and so on. And so you kind of keep going with it. And you say, okay, after 11 years, we're going to have 20 more. So that's 310. And after 12, 330, because you're adding 20 every single time, because that's the slope. That's 350. 370, 390, and so in 2015 you're going to have somewhere between 390 and 410. On to the next page, number 3, since the table shows life expectancy in years for people born in certain areas or in certain years. Construct a scatter plot using the data, then draw and assess the line that seems to best represent the data. So the first thing I need to do is label the scatter plot years since 1900, and then over here we're talking life expectancy. And so we have 0 and 47.3. I'm just going to go ahead and plot all of the data that they've given me. And I've constructed the scatter plot. Let's draw a line of best fit. We're going to put that as close as we can to all of the data. So there's my line of best fit. And now let's assess that. Most of the points fall on the line. So let's write the equation. So the first thing we need is the slope, and then we need the y-intercept. And it's crossing the y-axis right here at about 47. 47.3 was the value that they gave, but 47. And then we need 2 points on the line. So I'm going to take that first point, and then I'm going to take this point that's up here at 70, comma, 70.8. But I'm going to round it to 70. And this one was 0, comma, and we're going to use 47. So how much did we go up before we turned to go to the right on the slope? We went from 47 up to 70. So that was a change of 23. Then we turned and we went over from 0 all the way to 70. So 23 over 70. And I can put that into a decimal by dividing. And I get a slope of 0.33. So that's my slope. So my equation is y equals 0.33x plus b, which is 47. And so I interpret this as every year since 1900, life expectancy has increased by 0.33. In 1900, it was 47 years old. We have one last part to do. It says part C, use the equation to make a conjecture about the life expectancy for a person born in 2020. So 1900 to 2020 is 120 years, which is right here. I'm going to go up to my line of best fit, and then I'm going to go over. What value is it there? I would say it's at about 87 years. So bring these notes with you to class tomorrow. We will start with the practice problem in class. Have a good night.